There is gold on the moon, but in such small quantities that it seems almost like a cosmic joke. The concentration of gold in the lunar crust is only 0.00000011%. Now, compare it to Earth, where gold deposits were partly formed by the massive bombardment of meteorites billions of years ago. The moon, being smaller and with less gravity, wasn't as pummeled by those precious metal-rich meteorites. Think for a moment, how desperate would we have to be here on Earth to consider going to the moon to search for gold? It's like traveling to a deserted island to find a needle lost in the sand. Now, I throw this question at you. If we could overcome the costs and technological challenges to extract that gold, do you think it would be worth it? Not just for the gold itself, but also for what we would learn and the advancements we could achieve by doing so. On the other hand, there is helium-3, an almost magical element due to its potential as fuel for nuclear fusion. If we ever manage to use it efficiently, it could solve our energy problems in a clean and sustainable way. But I ask you, should we prioritize resources like helium-3 over gold, considering the benefits they could bring to humanity? How do you think we would decide what is more important to explore and exploit in space? Immediate economic benefit, like gold, or long-term impact, like helium-3? Helium-3 is truly a fascinating topic because, unlike gold, its value isn't in jewelry or immediate economy but in the future energy of humanity. This isotope, which is practically non-existent on Earth, could revolutionize the way we generate energy. Imagine a fuel that can power nuclear fusion reactors without producing dangerous radioactive waste or contributing to climate change. It's like having the key to a clean, efficient, and almost unlimited energy supply. And why is it on the moon? Here's an interesting detail. Helium-3 reaches space in the form of solar wind, but the Earth's atmosphere and magnetic field protect us, preventing it from being trapped in the soil. The moon, having neither an atmosphere nor a significant magnetic field, has been accumulating small amounts of helium-3 on its surface for billions of years. So, in a sense, it's as if the moon has been a natural storage chest for this resource. However, extracting it wouldn't be easy. Helium-3 is trapped in lunar regolith, that dusty layer covering the moon's surface. To collect it, tons and tons of regolith would have to be excavated, heated to extreme temperatures, and the gas extracted. It's estimated that around 100 tons of regolith are needed to obtain just a few grams of helium-3. And let's not even talk about the logistical costs, sending machinery, maintaining teams, and bringing helium-3 back to Earth would be extremely expensive. Now, let's return to the interesting question. If helium-3 could generate a clean and virtually unlimited energy source, wouldn't that justify those enormous costs? Imagine a world where we don't depend on fossil fuels, traditional nuclear reactors, or batteries that require rare and polluting metals. We could change the future of humanity, but are we ready to prioritize something so long-term? Let me ask you a question. If resources were limited and you had to choose, would you bet on gold, with its tangible and immediate economic value, or on helium-3, which could transform our civilization in the long term? What do you think our leaders and economies would say? And you?